Okay, I'm back with the second set of useful commands. This time we're gonna look at arrays and vectors, matrices, stuff like that. So, and maybe a few of them were kind of mentioned implicitly in my previous videos, but here I wanna focus on them specifically. So, three of them are for two sets. Okay, so if you have a set X which has a bunch of numbers in it 1, 2, 4, 6, 7, 9, something like that, and then set Y which is like 3, 5, 8, 9, and 11. Okay. And then if you want to know which of the numbers between these two sets are common, you want to find the intersection between them. So you use the command intersect, then you pass to it x and y, and it says, hey, the only number they have in common is 9, and you can see that. And then you can use the command union and say, hey, combine them together and count the common numbers only once. And you see it does that, right? So this is like all of these numbers together, but 9 that is common is just counted one time instead of two. And then you can have difference between them, like a minus b or b minus a, in this case like x minus y. And for that, you can use the command setdiff and say, hey, what is it that is in x but not in y? Just unique to x. And you see all of the numbers except for 9 are basically unique to x. So that's this guy is the same as what? X minus y. But you cannot say x minus y because the dimensions are not the same, and that is different from subtraction of member by member. Okay, so the command setdiff is the difference between two sets. So these three commands are for sets. And that's interesting. And another thing you can do for sets also, or an array, is the command unique. And unique is an interesting command which show you which members in A are unique. Okay, so for that I need maybe a new set which has some numbers that are repeated and also non-repeated. So then 5, 5, 6, 6, 6, 6, something like that. Okay, and now if I say unique of Z, look, it says 1, 2, 3, 4, 5, 6. So this is the same as Z, but each number that is repeated is only counted once. That's the unique thing. So these two ones, only one of them is unique. The other one is just repeated. The same goes for 2 and 3. They are just really, there is only one of them. And then 4, 5, 6, just one of them count. So if you want to know the unique members of a set, you can use the command unique. And that is interesting. By the way, if you want to know how many times each member is or each value is repeated in a set, you can use the command tabulate. So you can say, hey, tabulate for me the Z. And you can even get the result of that to another variable like tab Z, something like that. Okay. And it shows those members, those unique members, as you can see, and then it shows you in the second column the frequency of them. It says, hey, 1 is repeated 2 times, 2 and 3 only 1 times, 4 is 3 times, as you can see, 5 is like 2 times, and then 6 like what? 5 times. And on the third column, these frequency numbers are divided by the total number of frequencies, so that's the frequency percentage, basically. Okay, so for example, if somebody says which number in Z is repeated more than any other number, then you have to look at either second column or third column and see which one has the maximum value, right? So if somebody says, hey, I give you set Z, tell me which number in it is repeated more than anything else, okay? And one thing you might say is, well, I use the command mode. I say mode of Z, and that is 6. That is exactly right. You can do that. Or, as I said, you can come to this tab Z and look at second or third column and find where that maximum is happening. So it's going to be like max frequency and max frequency index. This is equal to the max of this tab Z, like second column, something like this. So it says, hey, the maximum frequency is 5 and the location of that is 6. And in this case, this is not really the value, it's just by chance, because 6 is like, it sorts them, okay? It sorts those unique numbers, and 6 is like the last one with maximum frequency. So 6 here is the row. So if I want that value, I have to go to tab Z, column 1, and then use this max frequency index, and in column 1, and that will give you the value now that has the maximum frequency. Okay, another thing you can do is, if I give you a set like the one we had, you want to know if a number is in this set or not, you can use the command ismember. And this is a beautiful thing. So you want to know if number, for example, 7 is in this set or not. And you see here, it says what? It says, well, a bunch of zeros. So what did it do? It compared that 7 against each and every one of the numbers, and it returned a logical array of all zeros, which means none of them are equal to 7. So the answer is no, none. If even one of them was a 1, then yes, it would be existing in this set, at least in one location. So just wanted to tell you that, and now I have a few other commands I wanted to mention. So you all know about the command diag, right? So if I have basically a matrix, right? So let's say A equals 2, 3, 5, 6, and then add a bunch of other numbers, right? So just let's make it a 4 by 4 matrix like that. So if I say diag of A, you know, it gives me the diagonal elements, right? 2, 9, -1, and 8. And if I have a vector, using that vector, I can also form a matrix. So if I say B equals diag of the answer, so take these numbers and give me a diagonal matrix, you know, it basically creates a matrix of all zeros, but in the diagonal position, it places those numbers for you, right? So this one you might also know, but sometimes you don't want to put these numbers on the diagonal. You want to put them one above the diagonal or one below the diagonal, okay? So if I say, hey, B is diag of the same numbers, right? It was 2 and 9 and -1 and 8, but I give it an extra input and say 1. What does that mean? Look, first of all, here, these numbers now, they have to go 1 unit above the diagonal. So this is the diagonal. They are 1 above the diagonal, and for that reason, now the matrix has to be 5 by 5, not 4 by 4. And you see they are placed 1 unit above the diagonal, right? Or if I say 2, they go 2 units above the diagonal. As you can see, now it has to be 6 by 6. And I can use -1 or -2, and they go below the diagonal 2 units. And again, it has to resize, but I just wanted to show you this extra input that you can pass to the diag of a vector and create a matrix that is basically a bidiagonal matrix. Okay, the last two commands that I want to tell you are for basically changing the locations of rows and columns within a matrix, or just the numbers within an array, and kind of flipping it or doing a shift on it, a circular shift. So if I have just this, let's say, vector A, and this A is equal to 2, 4, 5, 1, 6, 0, 9, right? Now, if I want to Filp it, so bring that 9, that is the last element, put it at the first element, that 0, which is 1 to the last, bring it as the second element, and basically flip it, I can use the command Filp left right of A. And you see here, that's what it did. Okay, so it flipped it left to right. Is there another way to do it? Yes, you can say A, and from end go with an increment of -1 to 1. Okay, and that should generate the same thing. So this is Filp left right. Okay, and if it's a column vector, you can do Filp up down. So for example, if I say B equals A transpose, right? Now I can do a similar thing with Filp up down. So I can say Filp up down of B, okay? And you see it does that. And if I have a matrix, right? So let's bring that same matrix that I defined earlier, this guy. Now I can Filp the whole matrix left to right or up down. So look here, if I say Filp left right of matrix A, you see here that the last column is now the first column, the third column is the second column, the first column is the last column. So it's left right, or I can say what? Filp up down. And if you look now compared to this, so this first row is now the last row, and that last row is now the first row, okay? So I can do that. Another thing that is more powerful is called circular shift, okay? So it's circshift, and you pass to it A, and then you tell it the number of shifts for rows and the number of shifts for columns. So for example, if I say 1 and 0, what does it mean? It means shift all the rows by 1, but nothing for the columns. So let's compare it against A. So what happened here? Look, this one, what happened? It went down, it came right down here, and then this guy went up, and then this guy went up again, you see? So the rows are circular shifted, not completely mirrored, because those Filp left, right, and up, down, these are like mirror. But here, like all the rows are going one up, and this row that has nowhere to go, one up, it comes back and becomes the bottom row, right? Now, if I say shift them 2, then each one should go up by 2. Look what happens. So this is A, this is this guy. So now this one is going to be shifted up 2, so that is going to go and sit as my top row. This one goes 1 up here, and then for another one it has to go to this up space here where there is nothing, so that makes this guy come and sits down again back as the bottom row. This one here, now not only it goes to this one, it should go to here because it's shifted 2. So look at that, it's here. And here is changing the column, circular shifting the columns by 1. This is A, this is the circular shifted version of columns by 1. Look at the first column of A. You see now it's the second column of this shifted version because it's shifted by 1. and the last column of A, it has to go to the right. There is no place for it, so it goes back and sits in the first column. And if you want, you can combine, right? So you say, hey, shift rows and columns by 1. Now that is going to make it a little bit messier, right? Because now look at this. This 2, 3, 5, 6, you won't see it anywhere here. Why? Because it went up and to the right. So what happened to it is this portion of it, this 2, 3, 5, if you look at it, that's like here. And then that 6 is here. Okay, or this 5, 3, 8. Look at that 5, 3, 8, right? Where is that 5, 3 or 6, 5, 3? Where is that 6, 5, 3? It's here. And then that 8 of it is right there. So this circular shift is an interesting command. Just wanted to let you know about it. So what we did in this video, if you look at it, were all of these commands. So hopefully it was useful to you, and I'll see you in my next video. Thank you.